Hello everyone, welcome back to my channel. Today we are going to talk about the large intestine, and without wasting much time, let's jump straight in. We find that the large intestine or colon serves as a reservoir for the liquid emptied into it from the small intestine, and the primary functions of the colon are to absorb water, maintain osmolality or levels of solute of the blood by excreting and absorbing electrolyte substances like sodium and chloride from the time, and it also stores the fecal material until it can be evacuated by defecation. We also find that the large intestine also secretes mucus, which aids in the lubrication of the intestinal content and facilitates their transport through the bowel. We find that the time is reduced by absorption in the colon to around 150 mils. The residual indigestible matters, together with slowed of mucosal cells, dead bacteria, food residue not digested by the bacteria, and this constitutes the feces. These are the constituents of the feces. We find we have the indigestible matter, we have the slowed of mucosal cells, dead bacteria, food residues. All those make up the feces. You find that the mucosa of the large intestine is punctuated with numerous crypts that absorb water and are lined with mucus secreting goblet cells. And at the lower end of the rectum, the circular and longitudinal muscle layer terminates in the internal and external anal sphincter. The colon also contains large number of bacteria, and they contain large number of bacteria that synthesize niacin, also known as nicotinic acid. It also has thiamine, also known as vitamin B1 and vitamin K. The large intestine can be divided into various sections. We have the cecum, we have the ascending colon, we have the transverse colon, we have the descending colon, and we have the sigmoid colon. So let me show you all these segments of the large intestine through a diagram. Here is the we have the cecum here. You can see it clearly. Then we have the ascending colon. It ascends from the cecum going towards the transverse colon. It's transverse. Then we have the descending colon, then the sigmoid colon. Then down here we have the rectum and the anus. That's how the large intestine is distributed. So we find that the inner surface of the colon has many crypts that are lined with mucus glands and numerous goblet cells. And we find that within the mucosal lining, within the large intestine, we have no villi compared to the small intestine. In the small intestine, we have the villi, but if you come to the large intestine, we have no villi, and there's also absence of plicae circularis. They are not found in the large intestine. Another character we now we let's talk about the common characteristic of the colonic mucosa. This mucus the mucus layer of the colon. And we find that the colonic mucosa are deep tubular pits increasing in depth towards the rectum. And we also find that the inner layer of the muscle of the large intestine is wound with a tight spiral around the colon. Therefore, contraction results in incompatibilization of the lumen and its content. The word was a little bit tricky to pronounce, but I did it. We also find that the spiral of the outer layer follows a loose undulating course, and contraction of this muscle causes the content of the colon to shift forward and backward. Now let's talk about the blood supply of the large intestine, and we find that the arterial blood supply to the large intestine is by the branch of the superior and inferior mesenteric arteries, which branch off from the abdominal aorta. And we also find that the hypogastric branch of the internal iliac artery, which supplies blood to the pelvic walls and the viscera. It also supplies blood to the genital organs, the buttocks, and inside of the thigh. Then we also find so here is here's the blood supply. Here's the aorta. Then here's the inferior mesenteric artery. Here's the superior mesenteric artery. That's kind of a brief diagram talking about the blood supply of the large intestine. Then we also find that now let's talk about the venous drainage, and we find that this eventually drains into the superior and in the inferior mesenteric vein, which ultimately joins the splenic vein to form the portal vein. And contraction of the colonic motility is stimulated by mastication and by the presence of fat and absorbed bile salts. Then we also have bile acids and the peptide hormone gastrin and the cholecystokinins. Those are the ones responsible. Those are the substances responsible for the contraction of the and colonic motility. The hormone secretin, glucagon, and vasoactive intestinal peptide acts to suppress the motility of the colon. So we have the ones that stimulate motility. That's when we have the substances that stimulate motility. Here we talked about the presence of fat and absorbed bile salt, bile acids, and the peptide hormones peptide hormone gastrin and cholecystokinin. Then the ones that these ones kind of suppress the motility. We have the hormone secretin, we have the glucagon, and we have the vasoactive intestinal peptide. And I think that's all we have for today's presentation. This with the arterial blood supply, I happened to explain it before. So that's the end of my today's presentation about the large intestine. Let's meet in my next